Welcome back to Chem Talks. Today, guys, we're going to continue our discussion on energy. But before we get going on the new information today, I want to review a couple things that we talked about last class. Specifically, how we measure energy. We came up with the term calorie, and that's the quantity of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. So if we have 1 gram of water, which is 1 milliliter, how much energy is required to increase the temperature by 1 degree? Related to that, we talked about the kcal, or the big C calorie, right? Big C. We said that was the amount of energy required to raise 1,000 grams of water by 1 degree. And that 1 big C calorie is equal to 1,000 calories. But remember, calories is more of a biology term than chemistry. In chemistry, we used the SI unit, which was the joule. Okay? And the joule value is 1 calorie is equal to 4.184 joules. So these are things we talked about that you should remember from last time. I told you you're going to need to memorize these two values, so make sure you have them. So today we're going to continue on talking about this energy, something called specific heat, which is almost identical to calorie, the idea of calorie, except we're not talking about water. We're talking about other substances. So we can define specific heat as the quantity of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. So we're not just talking about water. We're talking about any substance here. It could be water, could be iron, could be aluminum, could be copper, could be mercury for that matter. So all substances have their own specific heat values. One of them that you will need to know is specific heat of water, which lucky for you is pretty easy. Okay, it's equal to 1 calorie per gram degree Celsius, so it takes 1 calorie to raise 1 gram by 1 degree Celsius, or more commonly 4.184 joules per gram degree Celsius. Please make sure you write these down and memorize these. Okay, you'll need to know these. All the other specific heat values I will give you, but the water one we do want you to know. So we can take specific heat and actually make an equation to calculate it. It looks something like this. Heat energy, that's just energy, remember we called that Q, divided by your mass times delta T. Delta means change, so that's a change in temperature. So the heat energy divided by mass times the change in temperature will give us the specific heat of a substance. Now our units for this, heat energy, remember, is joules, mass is gram, and temperature change is going to be in Celsius, so it's joules per gram degrees Celsius. And yes, it does need to be in Celsius, so it's in Fahrenheit you'll have to convert. Okay, so copy this down, then let's do the practice problems here. Try this. When 20 grams of a substance absorbs 200 joules of heat energy, its temperature is raised from 15 grams Celsius to, from 10 degrees Celsius to 15. What's the specific heat for this substance? So let's identify what we have. First thing, we have 20 grams. Well, grams is our unit of mass. We have 200 joules. Joules is our heat energy, and then we have our temperature. Okay, so when we set our equation up, we're going to have 200 joules divided by our mass of 20 grams times delta T. Well, 15 minus 10 is 5, so we get 5 degrees. And multiply this all together, and we get 2 joules per gram degree Celsius. Here's our joules, gram, degrees Celsius. Pretty simple problem. Make sure you copy this down so you'll have examples when we do work more problems in class. Another problem. This time, rather than finding specific heat, we're going to find how much energy is required to do something. So look at this problem. It says how much energy, or heat energy, in joules is absorbed when 55 grams of water is heated from 20 degrees Celsius to 35. So first thing we have to do is find heat energy. And the way we do that is rearrange our specific heat. Remember, specific heat is equal to heat energy divided by mass times delta T. This time we want heat energy, so we're going to rearrange it and find that heat energy is equal to specific heat times mass times delta T. Just doing some basic algebraic manipulating our equation there. Okay, so we have a mass of 55 grams. We have our delta T's. Now what we need is specific heat. Well, remember, this is of water, so we know that from the last time we said the specific heat of water was 4.184 joules per gram degree Celsius. So we set it up in the factor labeling, kind of. 4.184 joules per grams degree Celsius times mass, 55 grams times 15 degrees Celsius. Now check what happens to our units. Our grams cancel there, and our Celsius cancel there, leaving us with just joules. Note our grams per degree Celsius is on the bottom. It's not up here on the top. This way they cancel out. We do the math and come up to 3,451.80 joules. So pretty easy to do. Just manipulate the formula a little bit to come up with your heat energy. The second quantity we're going to look at is heat capacity. And heat capacity is related to specific heat. But rather than looking at 1 gram of a substance like specific heat does, heat capacity is going to look at the whole entire object, the whole mass of it. We can define it as the amount of heat needed to raise the temperature of an object or substance by 1 degree Celsius. So how much energy does it take to increase the entire mass by 1 degree Celsius? And to calculate this, we need to know two things, or it depends on two things. The object's mass, how much of it is, and then its composition. So our equation is specific heat times mass. Your specific heat relates to the composition, then there's your mass. Okay. Our units for this are going to be joules per degree Celsius. So how many joules does it take to raise it per degree Celsius? And we'll see in this next slide how we derive that. So let's try a practice problem. Okay, so what's the heat capacity in joules of 325 grams of water? Okay, well, we know the mass, okay, and we know the heat capacity of water because that was one of those values that we needed to memorize. So we write it out this. Here's our heat capacity of water, 4.184 joules, and once again, per gram degree Celsius. Remember, the per means put underneath, times your mass. Your gram will cancel out, and you'll leave us with joules per degree Celsius. When we calculate this, we find it takes 1,359.80 joules to raise water by 1 degree Celsius. So pretty simple. And here's just some kind of background information here for you on different specific heat values. You can see there's a wide range of them. Let's look at two of them, for example. Let's look at copper and aluminum. Why? Well, these have real practical applications. Let's say you want to go out and do some cooking, but you don't have any pans, so you got to go buy some pans. You can buy copper ones or you can buy aluminum pans, but look at their different specific heat values. Okay, for copper, it's going to take 0.385 joules for every gram it weighs versus aluminum, it's 0.902 joules to increase temperature. It's almost 3 times as much energy is required to raise the aluminum by 1 degree Celsius as a copper. So copper might be a better choice if you're making pans, if you're cooking, because it'll heat up quicker than the aluminum will. You can see we have a high one. Gasoline has a really big specific heat. Water is a really high one as well. It's one of the unique properties of water. Alright, let me have you try this problem on your own and bring it into class, and we will go over it. Bonus points for whoever reminds me that we need to go over this, because I'll forget. So the question is, how much energy does it take to raise the temperature of 2 different 150 gram frying pans? One's aluminum and one's copper, from 50 degrees Celsius to 100 degrees Celsius. Say you're getting ready to cook something on the stove, and we need to know how much energy we need to put into it to get it up to 100 degrees where we can do our cooking. So try this on your own. You're going to give me an energy value for the aluminum and energy value for the copper, and we'll talk about... Alright guys, today we talked about 2 new concepts. Specific heat, which is how much energy does it take to raise 1 gram of any substance by 1 degree Celsius. And then we also talked about heat capacity. How much energy does it take to raise the entire mass of a substance by 1 degree Celsius? A couple of values you got to remember. The specific heat of water is 4.184 joules per grams degree Celsius. Please do this practice problem on your own. The specific heat values were a little bit earlier for aluminum and copper, so go back and look at that. If you have questions, come in and see me before class, and take care. Talk to you soon.